Okay, what's going on, guys? Let's do this problem right here. The question is asking water at 5 degrees Celsius, density is given 1000 kilogram per meter cube, and viscosity is given right here, and flows steadily through 3 millimeter diameter and 9 meter long horizontal pipe at an average velocity of 90 centimeter per second. They are asking for the head loss and pressure drop and minimum pumping power required to overcome this loss. Let's see how we can calculate this one. So first of all, we have to calculate head loss. To calculate head loss, we use this formula. Head loss is equal to friction factor, right? Friction factors times length over diameter times the velocity head. That's v square over 2g. So this is what we are going to use to find head loss. Let's see what we use to find the pressure loss. Pressure loss is going to be something like it's similar thing. Friction factor times L over D, length over diameter, then times half rho V square. Right? This is what we are going to do this, use this. So let's to this one we know the length already. We know the diameter. Yeah, we know the V square. V is here. We know the G, and we have to find the friction factor, right? So to find the friction factor, I have to first of all I have to find the Raymond's number. Raymond's number can be found using rho Vd divided by mu, that is viscosity. So let's calculate this one. We know the density of the water, 1000 kilogram per meter cube, times the velocity. It's given in centimeter per second. Let's convert it to meter per second. That's going to be 0.9 because I'm dividing by 100, right? So that's going to be 0.9. Then diameter. So diameter here it's given in millimeter. So let's convert this one into meter. 0.003 meter divided by viscosity. That's 1.52 times 10 to the power of minus 3. And if I calculate this value, this one comes out to be 1776. This is Raymond's number, but we have to find the friction factor. So friction factor can be calculated by 64 divided by this number. So that's going to be 1776. That's going to give us 0.036, right? Now we have this one, we can calculate the head loss. So let's calculate this one. So this is 0.036 multiplied by length, that's 9 meter, divided by diameter, that is 0.003 meter, times v square, right? V square is going to be 0.9 meter per second square divided by 2g. So 2 times 9.81 meter per second square. So that's the values we have. Let's calculate this one. So if I go further and calculate this one comes out to be 4.46 meter. Therefore head loss is equal to 4.46 meter, right? That's the answer for the first question. Let's see how we can calculate the pressure loss. So this is A. Let's do the B part, pressure loss. So I have the formula right here. We have all the values, so we can directly plug in and find the values. That's going to be 0.036 times 9 meter divided by 0.003 times half rho is 1000 times velocity, that is 0.9 square, right? Yeah, rho v square. Then if I calculate this value, this one comes out to be 43.8 kilonewton per meter square. So this is our pressure loss. The third one, this is asking minimum pumping power required to overcome this loss. So this one can be calculated by W. So W is the power. AV, this is volume flow rate. Q, AV times pressure loss. Area, here it's a pipe, right? So it's going to be a circle right here. So we have the diameter already. So it's going to be 5d squared by 4. So 5d squared by 4, that's going to be 5 times 0.003 squared by 4. Dividing by 4 because it's a diameter, right? So that's why. Then times velocity. Velocity is 0.9 meter per second. Then we have this pressure loss. We have found it right here. That is 43.8 kilonewton per meter square. And if I calculate this value, this one gives us 0.28 watts. This is kilonewton. Yeah, it will cancel anywhere, yeah. So this is the value we get. This is our minimum pumping power required to overcome this loss. And that's how it's done. I hope you guys like this video. See you next time.